Okay, welcome to today's lesson. My name is Kakoma, and we are going to look at this topic calculus. And the first thing we're going to look at is the differentiating using the first principle. So we have so many ways on how we can differentiate, depends on the question. So today we are going to concentrate much on differentiating using the first principle. So when you're differentiating using the first principle, the first thing that you have to know, it is the what? The formula. Okay, so what is the formula? The formula is limit when h is approaching 0, you have f of x plus h cross minus the f of x over h. Okay, so this is the formula that we are going to be using when we are differentiating using the first principle. So let's look at the first example here. Examples number 1. We have y is equal to 5x. Okay, so what is the first thing that we are going to do? When you start differentiating this one using the first principle, the first thing you need to bring down your formula here, which we are saying limit when h is approaching 0, f of x plus h minus f of x over h. Okay, so what is our f of x? Our f of x is what? 5x. Then what is this x plus h? This x plus h also, it is going to be represented by that. But how are we going to substitute in there? So we're going to say limit when h is approaching 0. We have the coefficient of 5 here. You're going to put it outside. Then open brackets. This x is being represented by x plus h. So you write x plus h, you cross minus. What is the f of x? F of x is 5x. So you're going to write 5x. Okay. From here, what are we going to do? We are now going to expand over h. So 5 is going to multiply everything there. So we're going to have 5 times 5 times x, that is 5x. 5 times h, that is plus 5h, then minus 5x over h. Okay, so if we have seen here, we have 5x and we have negative 5x. When you subtract this to 5x minus 5x, we are going to have a 0. This means that limit when h is approaching 0, we are going to have we're going to remain with 5h over h. So we have the common h on top and h on down here. We can do what? We can divide. So this means our dy over dx is going to be what? 5. So that is our answer. So this example looks to be a very simple example. Let's try to look at the second one. The second example, let me just grab here. So the second example, we have 4 f of x is equal to 4x squared plus 5x minus 3. Differentiate this using the first principle. So like the way we know, our formula is limit when h is approaching 0 is equal to f of x plus h cross minus f of x divided by our h. So remember, we have x squared and we have just an x there. What are we going to do? So the first thing we are going to do with this one, remember this x is squared. So we are going to first take of our coefficient, which is 4, you open brackets, you have x plus h. Remember, this is squared. Then what is the sign which is here? There is a plus. So a plus also here where there's 5x, we are going to take off 5 outside and open brackets, x plus h close. Then you have minus 3. Then minus, this minus for the formula, the f of x is what? Is 4x squared plus 5x minus 3. You divide with what? With h. Okay. So now we are going to expand that. So we have limit when h is approaching 0. We have 4 outside. So this one going to have x squared plus 2xh plus sh squared. You close plus here we are going to have 5x plus 5h minus 3. This negative will multiply everything that is in brackets there. So we are going to have negative 4x squared minus 5x plus negative times negative plus 3 divided by what? Our h. Okay. From here now, what are we going to do? We now distribute this 4 inside there. So we have limit when h is approaching 0. 4 times x squared, we are going to have 4x squared plus 4 times 2, that is 8xh, plus 4 times h, that is 4h squared, plus 5x plus 5h minus 3 minus 4x squared minus 5x plus 3 over what? H. Okay. So if you have seen here, we have 4x squared, which is a positive, and there you have a negative 4x squared. So these, when you subtract them, they'll give you a 0. Which other one do we have? We have 5x, which is a positive, and we have another 5x, which is a negative. So these also, when you subtract, they'll give you a 0. We have also negative 3 plus 3. We are going to have also a 0. So this means limit when h approaches 0, we are remaining with 8xh plus 4h squared plus 5h over h. Okay, so we are saying limit when h is approaching 0. So we are going to look out for what is common here, there, and there. So you find that here there's an h, there's an h, there's an h. So we are going to factorize h. So limit when h approaches 0. When we factorize h outside, we remain with 8x plus 4h plus 5 over h. So you have h, these you can divide so that you remain with the limit. When h is approaching 0, you have 8x plus 4h plus 5. Okay. So when you reach here, we are saying h should be approaching what? 0. So that means where there is h in this expression here, you replace it with a 0. So I'm saying now dy over dx is equal to 8x plus 4. What is h? You put a 0 plus 5. So you're going to have 8x. 4 times 0 is going to give us 0, and you have remained with a 5. So our dy dx is equal to 8x plus 5. Okay, let's also look at the other one, which is the last example. Hope you are following. The last example. they are saying differentiate y is equal to 2 over 3x. Differentiate y is equal to 2 over 3x. So our usual, you get your formula limit when h is approaching 0, f of x plus h minus f of x over h. Okay, so here you look at the equation given. You have 2 over 3x. So this means you need to factorize the coefficient. So you're going to have limit h approaches 0, 2 over 3, open brackets, x will be represented by x plus h, close. Then minus, what is the f of x? The f of x is 2 over 3x divided by h. So we're going to distribute 2 over 3 into these brackets here. So we have limit, when h approaches 0, we are going to have 2 over 3x plus 2 over 3h minus 2 over 3x over h. So these and these, when you subtract, they are going to give you a 0. So we have a limit when h is approaching 0, 2 over 3h over h. So we're going to factorize. You have h there and h there. So these you can divide, and you have your dy over dx is equal to 2 over 3. This is your final answer. Thank you so much for watching. Next time now we are going to look at the next method that we can use to differentiate. In case this method fails to differentiate some differential equations, remember it's not all the equations that can be differentiated using the first principle, but they vary, depends on how the question comes. So watch out for the next video when we are going to look at the other method on how to differentiate. Thank you so much for watching.